coming up with a logistic model for your data, for any data for that matter. First off, logistic model, in this case, we've got an increasing set of data, and it looks like a logistic model would be good. We've got some concave up portion here and a concave down portion with an inflection point somewhere in the middle. In order to come up with a model, it's really a very similar process to coming up with exponential and power models. The algebra is right here, so you can feel free to pause the video and take a look at or write down the algebra. But essentially we're going to take our basic model, perform some algebra on it, and then take the natural log of both sides. That differs from a few of the other models in which we took the common logarithm, just log base 10. Now we're going to take the natural log, or log base e, of both sides in order to come up with this, not the big Y there, this circled model, which basically, just like we've done before, gives us a linear model that we can then find the linear regression line for through Excel. But the downside to a logistic model is big L is something that we have to guess, something that we have to know in advance. Oftentimes it's easy to do so. All we're going to do with our logistic model process is find little a and little b like we've done before, but L is something that we have to either know or guess. So in this case, we're going to guess something like 10. So we'll assume L is 10. And then the first thing we need to do here is have our ln of L divided by Y minus 1. And Excel does no order of operations, so this is perfectly fine. Those are just notes down here. We'll take this equal to ln, and you can see the note from Excel returns natural log of the number. Ln of L, which is C1. Notice I'll use the dollar signs to make sure that we call that exact cell, no matter where we move this to. B3 is where our Y value is, corresponding to this row. Then we subtract 1. Hit the go button, we have a log. We'll pull this on down. And then by graphing X with that natural log, we should obtain our linear model. So now we'll just insert a linear model, insert a new scatter plot and select the original X values with the Y values that we just found, the natural log stuff. If we hit the go button, we've got a roughly linear model. Looks like we've got an outlier right here. That second point looks to be a bit of an outlier, so right here. But we can come up with a linear regression line for this, add a trend line, use more options just so we can come over here and display the equation on the chart for our linear regression. And there's our starting point. So these are the values that we'll start with. Now, if you want to make a better regression model, for example, if you really think that that second point is throwing things off, you could use other means to come up with this model, which we've done a few of in the past. But basically, it would be changing the slope, bringing this down here, so it went primarily through the bottom 4 points and not this one. So you can play with this all you want to and get better approximations, but that's going to be our starting point. So we've got B, the B value, or the slope from our regression line, is the same as the B value for our linear model. So we'll just enter this in to start with. And A, little a, is going to be the y-intercept for that linear regression line. So we're going to go e to the a power. Excel reads e to the a as exp. And again, you can see in their notes, returns e raised to that power. So exp of 2.2288 will be our A value for the logistic model. Next up, we've got our L, A, and B, at least a starting point for each. So we just need to plug those into our logistic equation and come up with a model. So this is going to be equal to L, which is C1. Use the dollar signs. Oops. Divided by, now we need some parentheses, 1 plus A, which is an E1, times, we've got that E there, so that's EXP of the B times X power. So E to the B times X is going to be G1 times X, corresponding to this cell, will be an A3. And you can see the red parentheses to denote where we're at. So we've got these red parentheses go together, these black parentheses go together, help us keep track. Hit the go button, pull this down, and these should, again, these are our model values, so these should roughly replicate our original Y values. 2 is pretty close to 1.4, 4, 5, 7. Of all these values, the 4 is most different from the 3, looks like. It's furthest from the actual Y value, which makes sense because we noted this is the one furthest from that regression line, or it looks like the outlier. Okay. So we don't need this log anymore. I'll bring our other curve back in, and we'll display that logistic model with our original data and see how well we did. The X values are going to be our original X values. Y values now are our logistic model values. Hit the go button a couple times, and we see the model that we came up with. And again, that second point is the biggest outlier. And a reason for this first point being so low, predominantly, is because the x-axis itself, or y equals 0, is always an asymptote for our basic logistic model that we've come up with. So this is trying to bring that logistic model down towards that asymptote a little bit quicker. We could shift all of our data down originally in order to help with that and maybe make this a little bit better estimate, but we can also come up here and try different values for our L. If I change the L value to 9, you can see everything has been dipped very, very low. If I change it to 11, everything's above. We still don't have any more curviness to that logistic model though. Back to 10, which was our original guess, and this looks to be about the best model. In order to change the curviness, because right now our logistic model isn't very curvy, we really need to change the A and the B values. That will make it more or less curvy. Okay? And that's just something to play around with. But this process will get you at least in the right neighborhood for that logistic model. Then again, play with your B, A, and L values from there in order to get the model that you're looking for. If you have any questions, please let me know.